Hello. Hey, so we're going to talk about parallel and perpendicular lines, and in particular, we're going to talk about these slopes of parallel and perpendicular lines. Let me get full screen for you. So these two lines here, which I'm going to label one of them L and the other an M, these are parallel lines. Okay, parallel lines never, ever, 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 ever intersect. They just keep going on about their business, keeping the same distance apart from here to forever. Never intersect. Those are parallel. I'm going to call L and T perpendicular lines. Okay, and perpendicular lines intersect, meet, if you will, at a right angle. So when they meet, they make a right angle, and a right angle is a 90-degree angle. Okay, so where are we going to see perpendicular and parallel lines? Well, look up or look down at the ceiling. Parallel lines and perpendicular lines everywhere. These metal runners that hold the tiles in place, they want to be parallel to each other because we want to keep them the same distance apart because the tiles stay the same distance apart. We don't want them squeezing together at the end, so we have a hard time getting the tile. So, theoretically, they're parallel to each other. They may not be perfectly parallel, but that's the way it works. So I can trace along. So those would be parallel lines. Right over here, the cross beams want to be perpendicular to each other as we go because, well, we want them to meet at right angles because these tiles are rectangular and rectangles have right angles, so we want that to be the case. What if I were to draw a line on the floor following one of the tile lines like that? How would that line be related to this line up here? Now they're never going to intersect, but they're not parallel, right? Okay, so these two lines here, and this is just a story for another day, those are called skew lines. Okay, so we've got parallel, perpendicular, and I'm just going to write perp, period. Okay, parallel lines, perpendicular lines, and then we have skew lines. And skew lines, they're not in the same plane. So a line on the floor and the ceiling, they're never going to intersect, but they're certainly not parallel to each other, what we'd consider. All right, so let's look at parallel lines. Let's look at this equation right here. This equation's got an intercept of 2, and then it appears to have a slope of up 2 and over 1, 2, 3. Okay, up 2 and over 3. So if I were to write that equation, it would be y equals 2/3 x plus 2. Let's look at this equation. Intercept is negative 1, 2, 3, 4, 5. Intercept is negative 5. Slope, a rise of 2, and a run of 3. So this equation is y equals 2/3 x minus 5. These two lines are parallel. They may not appear to be because it might be an optical illusion or something like that. They're parallel, and you may notice their slopes are the same. Okay, so parallel lines have the same slope. That's important. Parallel lines have the same slope. Let's look at perpendicular lines. These are perpendicular, at least they're meant to be perpendicular as far as I can tell. They both get the same intercept, which is 0. 0, 0 as we go, but let's look at what's the slope of this line. Slope of this line appears to go up 2 and over 1. So my slope is 2 over 1, which we'd probably just write as 2, right? My slope of this line, this one, appears to go down 1 and then over 2. So down 1 is negative, over 2 is positive, so the slope of this line is negative 1/2. Do you notice anything about how those are related to each other? Okay, well, they've got the same numbers, but the numbers are flipped over, and one of them's positive and the other one's negative. Okay, so Matthew-wise, the slopes of perpendicular, that's what that means, lines are opposite reciprocals, which is a big word, reciprocals, but you've heard it before. So they're opposite reciprocals. Opposite means one of them is positive, one of them is negative, so we got to have one of each in the pair. And reciprocals means we just flip one of them over. So if one of them was 2/3, the other one would be negative 3/2. Okay, these are some examples of opposite reciprocals. If one of them was, oh no, let's just go with it. One of them was 5, the other one would be negative 1/5. Because we put the little 1 under there. So those are another pair of opposite reciprocals. Perpendicular lines, opposite reciprocals. Okay, hey, let's summarize. Parallel lines have the same slope. Period. Okay, perpendicular lines, their slopes are opposite reciprocals. Okay, opposite means one is positive, the other's negative. Reciprocals means flip one, get the other. Examples again, we'll throw another one out there. The slope of one line is 3/7, the perpendicular line, well, we're going to flip it 7/3, change the sign. Got a positive and a negative. Okay, these two lines would be perpendicular to each other. That's it. Two concepts. Stop. Take a moment. Read. Reflect. Ponder. Pause if you need to. That's all. That's what we've got. Parallel and perpendicular lines. Simple as that. Parallel lines have the same slope. Perpendicular lines, slopes are opposite reciprocals. So, thanks for watching. Hope you got that. Some practice problems associated with it, and you should do those prior to taking the benchmark. Thanks again. Talk to you soon.